All right, so this is the last section in chapter 3. We're really not going to learn a lot of new processes. It's more about what we've learned, applying it to models and real life situations. Okay? So exponential and logarithmic models actually appear a lot in data. Okay? So some of you take biology, physics, chemistry. These two types of equations, exponential and logarithmic, they have a place in all three of those classes. Now, you might not always study them in your high school classes, but they have a place in all of those classes. Okay? Can any of you remember a time in any of your science classes working with exponential functions or logarithmic functions? Yeah?
Well, like redirections are okay. Like not actually doing it in class, just like mentioning.
Okay. Yep. Half-life. Anybody work with half-life? Okay. That is exponential decay. All right. So whether you want to admit it or not, you've probably seen it outside of math class. If you go on to take further science classes, you'll work with it every so often. Okay. So the first example I want to come back to, or the type of problem I want to come back to, are our compound interest problems. Okay? So go ahead and read through that example. Basically, last week I was saying, hey, this is how much money you're investing. How much money will you have at the end of this many years? Now, what's the difference with this example? Okay, Jeremy, I just saw your hand.
This is how much money we want, and then how long will it take to get that?
Okay, this is giving us the amount that we're going to have at the end, as opposed to us finding that amount. So, how long will it take an investment of $1,000 to double? Let me remind you that A equals P times 1 plus R over N raised to the N T. So, what does 1,000 stand for? We are investing $1,000, so that is our principal amount. 8% means our rate is what?
0.08.
0.08. And if we want to double, what is our A value?
2,000.
2,000. So we have 2,000 equals 1,000 times 1 plus our rate is 0.08. This example is quarterly, so this is 4 raised to the 4t. Okay? Your first step is always going to be to take that A and divide it by the P. What happens when we take 2,000 divided by 1,000? We get 2. Do you think that's a coincidence? No. We wouldn't even need to know how much we were investing if we knew that we wanted our investment to double. Because if we are doubling our investment, A divided by P is going to be 2, no matter how much we invest. Does that make sense? Okay. Now, if you can take 1 plus R over N and get a nice number, I will let you do that. If you take 1 plus 0.08 divided by 4, you get a nice decimal that stops. What is it? You said yes, I thought you had it.
I know 8 over 4 is 0.03.
Okay, well, that's what I wanted. Okay. All right, from here, what do we need to do to solve for t? Say louder.
Logarithm.
Change it to a logarithm. So from here, we're going to write log base 1.02. It's awkward, but it's okay. Of 2 equals 4t. Go ahead and evaluate log base 1.02 of 2 in your calculator. Remember the change of base formula, you would type in log 2 divided by log of 1.02. And then with that number, what will you do? Divide by 4. Derby, how long will it take?
8.751 years.
It will take basically 8 years and 9 months for your investment to double. It's a long time to wait, isn't it? Seems like a long time, but it's really not that. In terms of investment, that's pretty quick. All right, let's talk about continuously. Continuously means we're using which equation? Hurt. Okay. So A is still 1,000, 2,000, P is still 1,000, but now we just have E to the 0.08 T. Connor, did you have a question or did you?
Yeah, she answered it.
Okay, perfect. All right, so same thing here. 2,000 divided by 1,000 is 2. Since we want our investment to double, okay, we wouldn't even need to know A and P. We know that A divided by P will be 2. Okay, so from here, how do we solve for T? Natural log of 2 equals 0.08 T. Since this is base E, then we're going to do log base E of 2 equals 0.08 T. Evaluate the natural log of 2. Divide by the 0.08. And Ryan, how long does it take?
About 8.684.
Does our answer make sense compared to compounding quarterly? Yes, it should take less time because the more times you compound, the more money you're going to make off of the interest. Okay? Questions there? All right. So at the bottom of your notes sheet, you have 3 graphs. You have an exponential growth model and an exponential decay model. Now, we know we have exponential growth versus exponential decay because we can look at what in the equation? Okay, graphically, it's going up versus going down. What about the equation? The exponent is either positive or negative. One of my frustrations with your problem set was us not being able to verbalize that in the second problem. Okay? We know that this is an increasing function, an exponential growth. We know we are growing because our exponent is positive. Over here, our exponent is negative, so we know we are going to decay. All right? In both of these models where we have a e to the bx, okay, y is always going to be our amount, okay. A is going to be what? So I should say amount after so much time, right? If we're talking about applying this to models. A, what does A stand for?
Initial amount.
Good, initial amount. Okay, if you plug in 0, e to the 0 is 1, so that A, that coefficient, should always be your initial amount. And then B is going to be where your rate is. okay, for both the exponential growth and the exponential decay models. Okay. Same thing is true for the logistic growth, okay? Now, logistic growth, this is something that we work a little bit more with in Calculus 2, so Calculus BC is where you would see exponent or logistic growth. So things that follow this model would be like spreading a rumor, okay? Spreading a rumor, it's going to spread really, really, really quick, but then the more people hear it, the more you're going to overlap with people who've already heard it. And so you get to a point where you start slowing down, right? And then you approach a certain max number of people that can hear it, right? If we spread a rumor in the school, there's only a max number of people in this school that can hear it. So it's going to start slowing down, okay? I think we've all experienced this today. Okay.
Congratulations on being in that today, so I reference it the least indirectly.
Now, when we get back from lunch, we are going to look at a fruit fly example and then a virus example. So we have 2 examples after lunch. Here we go. We are going to do example number 2, I think is what this one is labeled as, about fruit flies. Fruit flies are used often for research in biology. When I was in college, one of my best friends, she had to count fruit flies like so many times a day as part of like some research experiment. So they're very disgusting, but no, they're like, have you ever like left fruit on the counter for too long? Like, they almost look like little gnats. They have a very short lifespan. Anyway. After 2 days, there are 100 flies, and after 4 days, there are 300 flies. How many flies will there be after 5 days? Okay. First of all, it says that this is increasing according to the law of exponential growth. So what can we write? We can write that, right? Okay. What I'm going to go ahead and do is, since we were talking about days, I'm going to go ahead and change x to be t. Okay? T for time, since we're talking about days. All right? So, do we know the initial amount of flies? No. Do we know the rate that they are growing at? We don't know the actual, like, 5% or 10%. We know that they're growing, but we don't know the exact percentage, okay? So this is what we're going to need to do. We know that after 2 days, there are 100 flies. So there are 100 flies after, what did I say? 2 days? Okay, so V times 2. Oh. There we go. And we know that there are 300 flies after 4 days. So there are 300 flies after times 4. We need to figure out what the rate is and what the initial amount is. Okay. Thoughts?
Solve function for like A and then plug whatever that is into the other equation.
Okay, we have 2 equations with 2 unknowns. Do you agree? Okay, so Jackson basically described what strategy? Substitution. Solve for a variable, plug it into the other one. Okay, so Jackson, this was your idea. Which one do you want to take and solve for A?
We'll take the first one.
Okay, so we can take this one, and if we solve for A, that means we're dividing by e to the 2b. So we're taking 100 and we're dividing by e to the 2b. Right? Okay. Then we're going to take this and plug it in over here. So now 300 equals A times e to the 4 times b. Okay. Is there a way to rewrite 100 divided by e to the 2b times e to the 4b? There are two different e to the powers. I think we can combine them.
So like 100 over E.
But e to the 4b over e to the 2b can be simplified. What do we do with exponents when we are dividing? We subtract them. So this becomes 300 equals 100. E to the 4b minus 2b is 2b. Okay. Now this becomes a little bit more manageable, right? What's our next step? Divide by 100. Then we have an exponential equation that we can rewrite, correct? So we have the natural log of 3 equals 2b. So b is the natural log of 3 divided by 2. What is our rate of growth? 0.549. Pretty incredible growth rate, huh? Okay. Now, do you notice how I've written it two different ways? We're going to have to go back and figure out our initial amount. And so I went ahead and left b in terms of the natural log as well as approximating it. Because now we need to go back to here and figure out what A is. So we've already solved for A. A is 100 over E to the 2 times B. Well, B is the natural log of 3 over 2. What is our A value?
I got 33 and a third.
Mhm.
You can't have a third of a 3.
Okay, so let's talk about that. When we have real data, we're typically going to get some sort of a model that is approximating, in this case, the growth of our fruit flies. No, we cannot start with 33 and a third fruit flies. However, the model that fits our data points is having a y-intercept of 33 and a third. Okay? You guys remember doing lines of best fit? Okay? That's kind of what's happening here, where we're taking two data points and we're modeling an equation. Okay? No, we can't have a third of a fruit fly. However, this is the equation that is best fitting our model. All right. So now we can figure out how many fruit flies we have after 5 days. Let's go ahead and write our model. Y equals 100 thirds e to the 0.549 t. Okay, so all I did is I took A and I put it here. I took B and I put it here. So A times E to the BT. Okay. If we want to know how many fruit flies we have after 5 days, we can plug in a 5 for time. What do we get? 500 and what? Obviously, we can't have 0.8 of a fly, right? But we can probably count on having 518 fruit flies, for sure. We are modeling the data. Doesn't mean it's going to give us exactly what's going to happen, right? But if it keeps up with this growth, we're going to have around 518 flies. Yes. I'm not going to be too picky about it. I mean, you might as well, but I'm not going to be super picky. Okay, other questions? Okay. Your next example is about a college campus with a contagious flu virus. Okay, if you think about college, not everyone, but a portion of the students live on campus. Everyone's going to classes on campus. Illness is going to spread pretty quickly on a college campus, as it would here in a high school where you guys are interacting with each other throughout the day. Okay? So the virus is modeled by this. What kind of model does this look like? It's a logistic growth. Okay, on a college campus. Okay, if an illness spreads, right, it's going to spread really fast, and the more you're exposed to it, eventually the less people are going to get it. Okay. The college will cancel classes when 40% or more of the students are infected. Okay. So how many students are infected after 5 days? What do we need to do with our model and the number 5? Plug 5 into T. Okay, this is basically a calculator exercise for you. Y equals 5,000 over 1 plus 4999 e to the negative 0.08, negative 0.895. After 5 days, how many students have the flu? 54.019. Okay, so real life, 59 students have the illness. Okay. Questions on how we got that in our calculator? All right, now, after how many days will the college cancel classes? We said that the college will cancel classes when 40% or more of the students have the illness. So what number do we plug in for which variable? 2,000 for Y. And how do we come up with 2,000? Okay, we have 5,000 students. 40% of 5,000 students is 2,000 students. to solve this equation. Okay, I see that our variable is in the exponent. And so our goal should first be to isolate the e to the power. What could be our first step? Carolyn?
I would multiply both sides by that big parentheses thing.
Okay, take that denominator and multiply it to the other side. Okay, one step in the right direction. Now what can we do? Divide that 2,000 through. I would not take the time to multiply it through because eventually you're going to have to divide it over anyway. 5,000 divided by 2,000. Badass. 2.5, whatever you want. Okay. Then what do we get to do? Subtract 1. Before we can change to logarithmic form, base to a power has to be isolated. So we need to divide that 4,999 over. I would just write it like that until you can put it into your calculator. I don't like how that looks, the decimal inside of a fraction, but I would not put it in your calculator and then round it because you're going to have to use it again later. All right? So just leave it like that. Now we can write this as log base e of that 1.5 divided by 4,999 equals negative 0.8 t. Okay. So now we can punch this ugly number into our calculator and then divide it by the negative 0.8 to get t by itself. So it can give me the decimal approximation for t. What do you have?
I got 10.139 meters.
Are you getting the same number?
Yeah.
Okay. So what's our answer? Well, I would say after 10 days they're gonna make during the 10th day. Well,
It'd be like, hey, and then class. 40%.
let's see. How do we want to think of this as? So
Yeah.
It'd be 3:20 a.m. just in case you're interested. You know.
So
of this made up virus. I would be fine with just saying after 10 days. After 10 days, right? They're gonna have to make the decision to cancel classes.
How do you think the account will be worded better?
they're all dying. It just died. It says long lasting.
But
that
yes,
Oh.
long lasting.
Oh.
Long
Can
lasting.
someone
So
in this class go on vacation and come back with a contagious
no, we don't want that to happen. Okay, there have been times where like schools have had to close because so many people get sick, especially like during the cold and flu season. There have been some nasty illnesses that take out the majority of the school, especially like if your school is smaller, not as many students, higher possibility for you to have to cancel school. All right, so your homework is on your gold sheet. You have some time to get started. As you begin your homework, I'm going to pass back your problem set.